Welcome to Unit 8. In Lesson 8.1, we're going to cover two main topics. This first topic we're going to cover is the average value of a function. And we're going to start by kind of going through a process of discovering what this means, average value of a function. So let's start right here. Draw a horizontal segment from x equals a to x equals b, which represents the average height of f of x on this interval. So if I look at this, it looks like the max is probably there, and then b is there. So if I wanted to look at what the average height would be, probably be about there-ish. Now it says, find the area of the rectangle formed. So the area of this rectangle, this average height rectangle. So rectangle is length times width. So the width is from A to B. So the width is going to be B minus A. That'll give me how wide that is. And the height is right there. So we could say that the integral from A to B is the b minus a times the height. If we solve that for the average height, we end up with this equation. Divide by b minus a on both sides. This is the equation, or it can also be rewritten as that we call the average value of a function. So we basically take the whole integral, we divide by the width, and that gives us, on average, what's the value of this function. And this should form some connections for you, because we've memorized for years that average is where you add all the numbers together and divide by how many there are. We know that that's the average. Well, this is adding up all the space under the curve and dividing by how many there are, the width of the curve. So that's kind of what I use to remember it. The integral divided by the width is your average value of the function. So let's try that on our first example. We want to find the average value of this equation from 0 to 2 without using a calculator. So the average value is going to be the integral on this interval of the equation divided by the width of the interval. Or we can also put that width out front and write it like this. Makes it a little cleaner. Okay, well, let's solve this. So we get 1/2 in front. I can take the integral of x cubed pretty good. X to the 4th over 4 minus integral of x is x squared over 2. From 0 to 2, there's our limits. And this is going to be 1/2. So this is going to be 2 to the 4th over 4 minus 2 squared over 2 minus 0 to the 4th over 4 minus 0 squared over 2. And we can simplify that out to get 1/2. This right here is going to end up being 16/4. That right there is going to be 4/2. Sorry, pointed to the wrong one. That right there is my 4/2, and that all is going to be 0. And when we simplify all that, we get 1. So the average height for this function from 0 to 2 is there. That's on average where the height is. Okay, let's try one more example for this video, that links with this problem. Okay, last problem. We want to now use our calculator to find the value of c where f of c equals this function we found. So that's basically a fancy way of saying f of c equals the one we've got. So let's take our equation up here, f of x, plug in c, so c cubed minus c equals 1. And I basically want to solve this. So this is essentially saying, if I go up here on my graph, is it saying what x value here gives me this average value there. That's what we're solving for. So there are a couple ways you could do this. The easiest one is to go into your calculator and put that in y1, and you can just write it as x cubed minus x. Put that in y2, and then find where they intersect. If you plug all that in, you should get that they intersect at 1.324, which fits that picture that we drew. 1.324, a little past 1, so that looks about right. So that is all for average value of a function. It basically comes down to memorizing this formula and knowing that we will use this formula anytime it says average value. That's our key word, and then we plug it into that. That's it for this video. In the second video, we'll talk about accumulation of rate functions.